goodness to fit. The second case we have in this case, chi-square test of independence. So here what happened? So we let's take an example. Let's say we have plant A and plant B. Under this we have, let's say, grade 1 product or grade 2 product. Let's take in the hypothetical values. Let's say I've taken 5, 6, 2, and 4. So we are taking let's say total there. So we have here let's say 11. Then we have here 6. Then we have 7 here. Then 10. And we have 17 here. Grand total. So when we have a tabular structure and we are validating this plant A is independent for grade 1 and grade 2, or otherwise the plant B is also independent of grade 1, grade 2, or vice versa also. They are not dependent to each other. It means they are independent. Values are not dependent to individuals. So for that purpose, we make one critical table, or you can say contingency table. C table we call it. So C table formula would be so row into column divided by grand total. Row into column total, row total, column total divided by total, grand total. So which means here we 11 into 7 divided by 17. Here we write in this case 10 into 11 divided by 17, or you can shuffle it. So here we in this case we say 7 into 6 divided by 17 and 10 into 6 divided by 17. So we are getting some values. So let's write it down. 11 into 7 divided by 17. So we're getting 4.5 prox. Then here also we have 110 divided by 17. 6.47. So 42 divided by 17. 2.47. 60 by 70. 60 by 70. 3.52. So this is my observed values. This is my expected value. So we are getting difference here. So observed minus expected. The formula was observed minus expected square divided by expected. So we'll run this formula for each cell. So here we say observed is what? 5 divided minus 4.5. 5 minus 4.5 divided by expected 4.5. Similarly, we run this formula for the rest of the cases. So let's run this. So 5 minus 4.5 divided by 4.5 square. Sorry, to do the square part. So let me run this on Excel so that it save my time. Okay, I'll go for sheet 3. So we have 5, 6, 2, 4. Other one we have 4.5, 6.47, 2.47, 3.52. We are running a formula. Observed minus expected square divided by expected. Here's the formula. So the summation is what? We're getting chi-square value as to 0.45, let's say. Chi-square value is 0.45. 245. Let's say hypothetically. So I'm ending off on this 5. So chi-square outcome is what? We are getting this value. So in my case, my degree of freedom is what? I have 4 observations. So degree of freedom would be 3. My alpha is what? Again, same 0.05. So critical table value would be what? So earlier also we have tested this. So in that case, we are getting critical value as a 7 point. Let me see what was the value available. 7.815. So as my this value is less than this critical value, we can say null hypothesis is true. It is they are independent. Observers is expected as because this my critical table value is 7.81. And chi-square value is what we have this side, whatever that position is there. So we say it is less than this. We can say this null hypothesis stand true. That's a calculation part which you can take into consideration. That's a outcome we are getting from chi-square test of independence. So here the important point is what? Calculating your contingency table. So we have column into row into column, whatever you write, row total into column total divided by line total of frequency. That is expected value. That's a formula we have to make sure we remember while we are making contingency tables. So because contingency tables are required to compare your outcomes available with you, that's we consider as an observed outcomes. And contingency table will give me expected outcomes based on this formula.